these are, you know, what we're doing today, and then also the things that are due coming up, which we'll talk about them a little bit more, but make sure you do read the directions before you watch the video on it. And then the new video I sent out on Tuesday, that really kind of walks you through everything if you kind of watch that. But again, make sure that if you downloaded Office 365, you have to actually download and install the program on your computer, not just use the web-based one it gives you. It gives you a web-based one, which will get you through most of it, but won't let you do that regression line. So in order to get the regression line, you have to actually download the program and install it onto your computer. And you get that for free, so you might as well do it. It doesn't hurt to have it, unless you have it already, in which case you don't need it. All right, and then Sunday 11.3 is due, and then I'm talking about this grouped by exam part. So what that means is this. All right, so I'm going to give you exam 1 material, and within one exam material it will be mixed up. Exam 2 material, and within that exam 2 material will be mixed up, and then exam 3 material, and then exam 4 material. So it kind of go in order as you go through the exam. So within the exam it will be mixed, but the 1 stuff will come before the 2 stuff, before the 3 stuff, before the 4 stuff. Or you might get the other version where it goes the exam 4 stuff first, and then the exam 3 stuff, and then exam 2 stuff, and then exam 1 stuff. But it will be linear, either backwards or forwards, one way or the other. So then that's less that you have to, you can kind of have it go in some sort of progression. So it won't be completely confusing entirely. You'll have some sort of sense of it, a little bit. All right, and then also you make sure you have to upload your final this time. We're changing it. You have to upload it as a PDF. So there's videos on Canvas on how to use Cam Scanner to do that, or how to use Notes in the iPhone to do that. And then the other thing is you have to log into Zoom before the final in order to access it. So you have to log into our class Zoom before the final, and then I will grant you access. So let's go ahead and have somebody read this. Who hasn't read in a little while? Ian, go ahead and read.
Zoom to get into final. You must Zoom with me on your phone with video at the beginning of the final in order to access the final exam and confirm your computer setup. iPhone users need the Zoom app on your phone. Students will be put in the Zoom waiting room and admitted 8 at a time to scan their computer setup, place their phone out of arm's reach facing their workspace/computer area while they log into Proctorio to see the test. Once they are in, I will disconnect them from the Zoom meeting and let them in, or let them exit. You may enter Zoom starting at 10 minutes before your official exam time, and will have 180 minutes to complete the exam once you begin. Zoom into our regular class Zoom meeting. If you have any problems during the exam, I will be available during Zoom.
Great. So what you're going to do is this. You're going to get me up. Oops. There we go. So you're gonna get on the phone with me, and you're gonna be like, "Hi, Ms. Young, how you doing?" Right? And and then I will let you in. I'll open up the exam for you so it's available in Proctorio. And then you're going to show me your computer area. You're going to say, "Oh, look, see, here's my computer," and you're going to scan your area around your computer so that I know that you don't have something strange going on. And then you're going to put your phone far away from you, more than an arm's reach away, and then you're going to come back. And then you're going to log into Proctorio, into the test, and I can see that you've logged into the test, and you've started, and then you're going to do your regular scan thing, and whatever you do. And then once I know that you're in Proctorio, then I will disconnect you from Zoom, and I will turn you off. And drop you out of there. So that's how that works. Make sense? Everybody on board? And then your phone won't die because it'll be sitting over there, but it'll be just the Zoom will be off. And because once I dump you out of Zoom, then it'll just go to sleep and do its regular phone thing. All right, everybody okay with that part? Questions about that? I'll put the chat so I can see if there's any questions about that. Okay. All right, I don't. I don't know why the chat isn't opening up for me. All right. Moving along. The final, it covers chapters 1 through 11. You're allowed one page of notes both sides. You're also allowed all of your tables, Z table if you want it, T table, PPMC table, chi-square table, your magic formula sheet, and your TI calculator. Mac users, make sure you turn off pop-ups so you don't get kicked out. Right, and then PC users, make sure you restart your computer. Don't just turn it on and off because that doesn't reset the memory. Restart it. There's a little restart button. I don't know if you can see mine. Look at that. I'm not sure if you can see it. If I go down to the bottom under Power Options, it gives me an option to restart. Not shut down, but restart. And that's the one that you want. It's really slow. Okay. There's a couple of changes from last time. One of them is that you have to upload your exam work pages as one PDF file in assignments. It's going to make it a lot easier for me to grade it a lot faster. So take pictures of all of them and save them as one PDF file. There's directions and videos on how to do that using the free app Cam Scanner or Notes on iPhone, and videos on that are in Canvas. And you're going to save it in assignments. So that's different than saving it as in the quizzes. So if you go to assignments, then you'll see the thing where it says upload your final here, and then you'll put it into there under assignments. And again, I'm going to force it to be a PDF file. I will not accept a non-PDF file. All right, this is your study guide for the final, which you guys saw last time. I'll leave it up there for 10 seconds so you guys can take a picture of it if you need to. But these are all the problems from each of the study guides you should be focusing on to study for the exam. So just these, that's all you need. 5 more seconds. 5, 4, 3, 2, 1, 0. It's the same as it was last class. It hasn't changed. And then these are my office hours for next week. These are when I'll be available. It's going to be in my office hour Zoom, not in the class Zoom. Tuesdays are going to be review sessions. So I'll do a review session from 3 to 4:30, another one from 7 to 8:30. We'll probably go a little bit longer than 4:15 and 5:15. But those are the times for that. Take a picture of this if you need it. And then on Monday and Wednesday, you can also come in and ask me other questions if you have questions. Or if you need to talk about something, your grade or what you should be doing, and you can't meet at those times on Monday or Wednesday, email me and we can work some other time out for us to talk. Okay, all right, I'm going to move on from here. And next, so study guides are in here. If you don't have them, the Exam 4 study guide, you'll need to get from there. I also put in a new one that you guys should take a look at. So this is in our regular class Canvas. Just go down to this one. It's almost at the very bottom, Study Guides Practice Exams. When you go in there, you'll see these two at the bottom, these guys here. This one I'm going to put in, or I just put in for you guys. I'm going to put into the other classes soon, the finals review type of problem. And that one is it's 4 pages of just problem after problem after problem. Don't solve them. Just try to figure out what kind of problem it is. Is it an ANOVA? Is it a hypothesis test for a proportion? Is it a chi-squared matrix? Just try to figure out what kind of problem it is. And then the solutions for that are right below it. Where it says solutions final, what kind of problem? That's the solutions for the file right above it, even though they're named slightly differently. That's the solutions for the one right above it. So that will give you, usually I hand that out in class, and since we're not in person, I didn't do that, which is why I'm posting it in there. And I really recommend that you take a look through that, because doing the wrong thing to a problem will lose you most of the points for that problem. And that's going to hurt you a lot. It's going to be really painful. So you don't want to do that. You really want to, to make sure you sort out what kind of problem it is first before you, try to attempt to solve it. All right. Next, Lab 10. We talked about this part, right? the instruction files in Canvas under project. The data is under part 1 in the project, not 2, that's a typo. And then I did a video for you guys. Which kind of also answers some other questions. But here it is here. So what I want from you are 2 things. You're going to turn in. What if I did it? Yep. So you're going to want to email me your Excel file or a link to your Google Sheets file. And then also, you're going to take a picture, because the hypothesis test you're going to do by hand on a piece of paper and answer some questions after that. Take a picture of that with your phone, and again, save that as one PDF file and email that to me also. So I have a couple of videos on how to do this. I have one where I explained it into my class last semester, which is blurry. So you're going to want to read the directions first before you start watching that and follow that along in Excel and Canvas. I have a second video I've done that I did on Tuesday night because people had some serious questions. All right, so let's go ahead and do a quick review here. So here's 10.1 correlation coefficient. Again, we're going to be comparing, we're going to be estimating what we think our population rho is, our population coefficient, and we're going to be using our sample correlation coefficient R to do that. Correlation coefficients range from -1 to +1. That's their range. -1 is a perfect line with a negative slope. +1 is a perfect line with a positive slope. And then in 0 in here, this is just a bunch where it's not correlated at all. It's just a bunch of random dots, kind of like you can see kind of up here. These are just kind of random dots. Let me kind of make those more dot-like. This kind of got messed up. But just a bunch of random dots, basically it's like a 0, kind of. It's like a circle. It's just, they're all random. That means no linear correlation, no relationship. So we'll talk about, so what you're going to do is you're going to look up your critical value in the PPMC table, and then you'll stick it in here, the +1, you're going to shade to the right, and you'll put in the -1 of that same number and shade to the left towards -1. And then you're going to use your calculator to find R, and you're going to pop R in. If R goes in this section here, then we're going to not reject H0. But if R is in this shaded area out here or over here, then that's the guilty region, right? You have enough evidence you're going to reject H0 if it's out here or out here. And then how do we get R? We're not going to do this confusing, the big long formula. Instead, you can just use stat test ln reg t test of L1, L2. So you can put your x's into L1, your y's into L2, stat test ln reg t test for linear regression. The other thing you're going to want is your H0. So H0, remember H0 is always, for this one, this is chapter 10, is always going to be rho equals 0. Remember, null hypothesis is always no. No line, no correlation. Equals, right, equals 0. H0 is always equals because there's no difference. In this case, also no line, no correlation. No difference between rho and 0. H1 is rho is not equal to 0. Always, for chapter 10. That's the alternative hypothesis. That means that it is a line. There is a correlation, right? It's the opposite of these guys here. It is a line. There is a correlation. So the other thing is, if we reject H0, then it is a line, and you're going to use y equals a plus bx to predict. If you do not reject H0, if H0 seems correct, then it's not a line, and you will not use the line to predict. Instead, you're going to use y bar and x bar to predict. Your best predictors of the y's is y bar, the average y. The best predictor of the x's is x bar, the average x. Right? So, we all know that, for example, height and test scores are not correlated, right? So if I were to take my best guess at someone who is 5 foot, what their test score would be, it would be the average test score, right? So Y bar or X bar, depending on which one is test scores. Say if Y is my test score, so then Y bar, the average Y would be my best predictor. If there is a correlation, like for example, what's something that has correlation? Like number of things you purchased and how much money you spent, right? That has a positive correlation. So then you'd be using it. You would have rejected H naught because it's a line, and you'd be using the line that you got, the A plus BX line that you got from your calculator to predict it. See if I did that. So here is, well, okay, let me talk about step 5 first. So step 5 is always going to be this. This is chapter 10. Blank evidence, so either is or is not enough evidence of a correlation between blank and blank, whatever your X and Y are. So that's all you need to do for chapter 10. Use this for your number 1. Find your correlation, find your critical value, which is from the PPMC table, and you're going to put it in here, right there and there in shade. And then find your R using stat test, Lin-Reg t-test, and put it in wherever it belongs. And then again, we're going to reject. Step 4 is the same as it always has been, right? Reject in the rejection region, or don't reject if it's not. And then step 5 is going to be just this, blank. Either there is or is not enough evidence of a correlation between blank and blank. Okay, now that's the first part, the hypothesis test. The second part I'm going to ask you is predict. Predict, for a person who is 5 foot tall, predict their test score. So if we rejected H naught, then you're going to use this line up here. If we do not reject H naught, this situation down here in blue, then we're going to use Y bar or X bar. If you're predicting the height or the X, then you use the average X. If you want to know what the Y is, then you're going to use the average Y bar. How do you find that? You use 2-var stats. You go to a calculator and you do 2-var stats. So here's the Lin-Reg t-test, right? You're going to put your X's in a list 1, your Y's in a list 2. That should be not equal to. Otherwise, it'll screw things up. Frequency should be 1. Or on the fancy calculators, you'll just leave that blank, I think. And then hit calculate. And it's going to give you an A and a B. So if you don't have a correlation, if your data is not correlated, like for example here, see how my p-value is 0.52, my r value was like really close to 0 in this case, then I would not be using the line. I'm not going to use A and B. I'm just going to use the average Y bar. So I go to 2-var stats, L1, L2, and if I arrow down, I'll have to arrow down to get there, but the Y bar will be there. I'll show you guys. So I have some data into lists. I'll do stat, test, Lin-Reg t-test. If I arrow down, there's my A, there's my B, there's some other stuff. Here's my R. That's a pretty decent R. So here I might be rejecting H naught, and I would use Y equals A plus BX. So I'd be using these numbers. But if for some reason I don't reject H naught, then I would not use those. Instead, I'd do this: stat, calc, 2-var stats, and then I'm going to do L1 second, second 1, comma, second 2 to get L2. And then that will give me this. There's my X bar and stuff like that, but I want Y bar, so I'm going to arrow down right here, arrow down, and then I'll get my y bar. Okay. Questions? Anybody have any questions? You guys are very, very quiet. Okay. All right, so that's it for chapter 10. Chapter 11, there's 3 different things. The first one is the test of goodness of fit. So this is the chi-squared list. Okay, that's my other name for it is chi-squared list. That's what I call it affectionately. And that's where you have a list of data and that's observed, and then you have to calculate the expecteds. Right? I give you the observed, you have to calculate the expecteds, and then you have to write them all out. And yes, you do have to write them all out. There's only going to be 3 or 4 of them. It's not that hard. You write out, your first observed minus the expected squared divided by the expected. And then the next observed minus its expected squared divided by the expected, and so forth. And you can either just calculate those and add them up to get your test stat, your chi-squared, or you can use your calculator and do it that way too. Either one's fine. Here's an example. Right, this is a chi-squared list. So first of all, you'll notice that it's a chi-squared because there's proportions or percentages. So you got these percentages. It doesn't always have that, but if it does have a proportion or a percentage, then it definitely is a chi-squared. And because chi-squareds are all about proportions or percentages, where your data is categories. Right, so my data would be, what kind of bag did you use? I used plastic, or I used paper. I wouldn't say I used 4. You're not going to give a number as your data. You're going to give a category, a label, right? I used paper. So your data is, again, your data is going to be a label, right? Category. And I'll give you the observed. So here I give you the observed. 328 were paper, 120 were plastic, and the rest were remaining were reusable. And then you have to calculate the expecteds. Remember, I'm either going to give you the percentages, like here I gave the percentages, right? 60% here, 30% will be there, 8% will be there, and you have to calculate that, right? 60% of the total of n. So 0.60 times n, that tells you how many go into this expecteds for the reusables. Or it will say equally likely or no preference, in which case you take the n and you divide by how many you divide equally amongst the categories. So I'll take the 300, I'll divide it, I have 3 categories, so I divide it by 3, and that's how much goes into each category. Right, so you take your n and you split it, divide it by how many categories you have, because that's how many go in each one. And that can be a decimal. Absolutely will likely be a decimal. Could be, might not be, I don't know. We'll see. But at any rate, could be. And those are the ones you calculate. You always calculate the expected. You're always given the observed. Always for chi-squareds. So that's 11.1, and it's also true for 11.2. You're given the observed. The difference is here it's listed out. It's just one list. It's one thing, paper, plastic, reusable, that's it. And again, you have to write out, for your step 3, you have to write out all the formula, this minus this squared over that. Then you can calculate it any way you want. Some of you are actually going to have that nifty option in your fancy TI-84 calculator where it will calculate it for you. It's called the chi-squared GOF test or something like that. And you can use that to calculate. I don't care how you calculate it, as long as you write out these formulas here for me. So you can calculate that any way you like. The other one, 11.2, is the chi-squared matrix. So again, it's going to be categories, right? So someone might say, well, what kind of dog are you? Well, I am a yellow lab and I'm male, right? So that's the answer, right? It's a category. It's not saying, well, what kind of dog are you? Well, I'm 7. No, you're going to be, I'm a yellow lab and I'm female or I'm male, whatever it is. That's your data is categories. So this one, though, you're going to have two different variables, right? You're going to be a yellow lab and male or female, right? You're going to have two different things you're going to be doing. So it's going to be a contingency table. It's going to look like a matrix. And then you can either be an independent test or test of homogeneity proportions, and those are the same tests. So I'm not going to stress about that today, or this semester, or in general. But the contingency table, it's a two-way table where you have categories here and categories here. For 11.1, you only had categories along one area. You only had categories along the top, right? You had your, last time it was the reusable paper or plastic across the top, and then you had observed and expected. Here you have categories across the top. What kind of lab are you? And then also, what is your gender? You have two. You have categories here and here, along both top and side. So then you have this little matrix thing going on here of your data. Someone pointed out last class, they said, well, they'll have totals too, which may or may not be true. I may not give you the totals on the exam. So don't rely upon that. But there are at least two options here and at least two options there, and you have two different questions you're asking of each person, or each puppy in this case. Okay. So this one, it's the same formula, but I am not going to force you to use this formula to find your test stat. You can use the calculator to find your test stat. You do, again, still have to find your expected values, though. Expected values you always have to calculate. Remember, with the last one, your expected values, you calculated them by multiplying the percentage times n. That's how you calculate all your expecteds. This time, to count your expecteds, you're going to take the row sum times the column sum divided by the grand total. That's how you find the expected values. And you don't have to find all of them, because there might be, 6 to 12 of them. You only have to find the first one and the last one. That's it. Just to prove you know how to do it. Just calculate the first expected value and the last expected value. Oops. And I'll show you what I mean in just a second. But the test stat, this guy here, you don't have to calculate that or write that out for 11.2. You just have to put it into your calculator and do it. That's fine. Because it's a lot to write out, and you've already done that for 11.1. You don't have to show me again in 11.2. It's the same formula. So for 11.2, again, you're going to get your step 2 from your chi-square table, and you're going to draw your little picture. This is true from 11.1 or 11.2. It goes straight up and then out, and you're going to shade out this way. So 11.1 and 11.2, both your chi-squareds. You're going to use a chi-squared table. So the 11.1 was a chi-squared line. This is a chi-squared matrix. You're going to find your critical value. Remember, it's only right-tailed because it can only be positive. There's no negative side to it. You start at 0 and you only go one direction. So it's up and then out. I'm going to contrast it again and show you this is 11.1 and 11.2, the chi-squared ones. The chapter 10 is different. That's going to be, chapter 10 was this one here, right, where you have the line and you have the shading here and shading there. That's totally different. That's chapter 10, correlation coefficient. This is 11.1, 11.2, chi-squared table. You're going to draw it out like that, and it's always right-tailed. Okay. And then for step 3, you're going to calculate your expected value of the first one, E11, your row total times your column total divided by your grand total, and you'll do the same thing for your last one here. This would be E, second row, third column, so E23. Remember, it goes RC, RC Cola, Royal Caribbean, whatever you want to do, RC. Find it for the first and the last, and then you're going to, for the chi-squared, you're just going to put chi-squared equals, and then stat test chi-squared of matrix A, and you're going to write down what it is. The chi-squared is 13.7 or 5.629, whatever it is. And you're going to throw it into your table here, and step 4 will be, obviously if it's in the shaded area, you're going to reject H0. If it's in this unshaded area, you're going to not reject H0 for step 4. And then step 5 is always going to be this part here. Blank evidence that the proportions are equal. That's it. I don't care. You don't have to do anything fancy. All I need is that. You can be fancier if you want, but all I need is either is enough evidence or not enough evidence that the proportions are equal. That's it. And I'm happy. Questions about this one? So the step 1 for this is going to be the same as it was for the chi-squared, the other chi-squared, this guy. It didn't show it up there. It's going to be, I really don't show it up there. So step 1 for this one will be, go ahead, yeah, I can do it in blue, will be, right, that H naught is, oof, that's terrible, is rho is equal to 0. It's the same thing as the other one, as 11, 1. Those are the same. And then step 2, again, you get your critical value from the chi-square table. You draw a picture. Step 3, find your expected values, the first and last expected values, and then all you got to do is write in chi-squared equals stat test chi-square test of A, and then write down your value. That's it. Step 4, throw it in here, and then reject or not reject H naught, and then step 5, right? Okay. Questions? Am I not seeing the questions? Are there questions and I'm just not seeing them? Someone speak up if there's questions in the chat that I just am not seeing. Okay. Good deal. And then 11.3 is ANOVA, which is, I think, the easiest one for you guys to spot in general. H naught, again, is mu1 equals mu2 equals mu3 equals mu4, however many mu's you have. And then H1 would be at least 1 differs. Actually, I'm going to give you a summary in a second. This is the one where it's really complicated to find it, so we're just going to handle it like baby steps. We're just going to use the TI-8384 to get results. You're going to find the p-value from there. And the p-value, again, remember, the p-value is the probability of getting your sample. And our guideline for unusual is typically it's 5% or less, right? It's alpha or less. So if your p-value is alpha or less, then you're unusual and you're going to reject the null hypothesis. If your p-value is bigger than alpha, then you're not unusual, and the null hypothesis might be just fine. You didn't get anything unusual. The other thing I will ask you separately from the hypothesis test, this is completely separate, is I will talk about I'll give you the between group variance and the within group variance. And the ratio of this, the between group variance over the within group variance, is how you compute the F statistics. So here, for example, you have first graders, fourth graders, and 12th graders. So, you know that the first graders are all going to be like down here low, and they're going to be all, here, I'll back up a little bit so you can see me better. They're all going to be kind of right in this range here. And then the fourth graders, they'll be in this range over here. And then 12th graders, they'll be up here. And the within group variances aren't really big, right? But the between group variances is all the way from here to here. It's really large. So the between group variance is going to be really huge compared to the within group variance. And that's what this F statistic measures. So I will give you the between group variance and the within group variance and some other stuff. I'll either call it between sample variance or between group variance or variance between samples or variance between groups, something like that. But it's going to be the between one, the between variance, and I'll give you the within variance. And you need to find the F statistics. You just divide those two. That's it. That's not going to be part of the hypothesis test. It's going to be completely separate. But I just want you to understand the principle that that's where this comes from, even though we're not going to calculate it or really work with it because it's complicated to calculate to find these two things. But you should understand that that's what it's measuring. That's what the F statistic measures. And that's only worth a couple points, but it'll be two of the easiest points that you'll have. All right, so these are the 5 steps for it. Our H naught, all the means are equal. H1, at least one differs. You can't say which one differs because you don't know. You can't say that 1 is not equal to 2 is not equal to 3 because maybe 1 is equal to 2. You don't know which one is different. Just at least one differs. That's it. Step 2, super easy. Write down alpha. Alpha equals whatever. Step 3, also pretty easy. Compute the p-value. Put your first group into list 1, the next into list 2, the next into list 3, however many lists you have, and then do stat test ANOVA of L1, L2, L3, L4, however many lists you have there, and it will give you a p-value. Again, if the p-value is less than alpha, less than or equal to alpha, you're going to reject the null hypothesis because it's unusual. This is the opposite of what we've been doing. We've been comparing test stats, in which case when it's bigger, it's unusual. Here it's p-values, the probabilities. So remember, small p, when p-value is low, H0 must go. You're going to reject an H0. When the p-value is high, then H0 will fly. Then it's good. And then the summary is, as always, blank evidence that the means are the same. That always stays the same either. It's either going to be is enough evidence or not enough evidence. I'm going to switch to my phone audio because this is winding me down. So I'll leave that up for a second for you guys to take a look at while I dial in.
Welcome to Zoom.
Then
Enter your meeting ID followed by pound.
This is something else you guys should take a look at. I'll let you look at that for a minute.
Enter your participant ID. You are in the meeting now. There are 13 participants in the meeting.
Okay, good.
Professor Young,
Yes.
when do we use O sub I is equal to E sub I?
Yes. Anytime you have a chi-squared. Oh, crap. Did I just screw that up? Oh, no. I totally screwed that up. I suck. Wow, that was really bad. This is not. That's totally wrong. That's completely wrong.
Yeah, I don't think your audio was working because Jay was definitely trying to talk to you and you weren't responding.
Oh, no. Okay.
Yeah, you couldn't hear me, Professor Young.
Oh, no. This is totally wrong. Thank you, guys. All right. So, totally wrong.
So that was for chapter 10.
Yeah. Yep. This is this one. Yes. I'm so sorry. Completely screwed that up for the video, too, as well. So if you're at home in the video, hopefully you got this far and you didn't stop it earlier because I totally messed this up before. Don't do what I did before. This is my H1 and H0 for this one. Yes, I'm so sorry. Thank you so much. Right, because these are observed and expected. So chi-squareds are my observed and my expected. Wow, that's terrible. Okay, thank you.
So just one other question, Professor Young.
Yes.
For 11.1, both the chi-square list and the chi-square matrix, you want the step 5 to be blank evidence that proportions are equal?
Yeah, I'm good with that. I'm fine with that.
Okay.
Technically, this one should be are as stated, but if you say are equal, then that's going to be okay.
Okay. Both for the list and the matrix.
Yeah. Yeah.
Okay.
If you do that, I'd be okay with that. Okay. So Thank you for correcting that. And, oops. So this is something we talked about last time. I revised it a little bit based upon yesterday. So chapter 10 is going to be our, this is our chapter 10 stuff. Right, so it's when you have two variables and the data is numerical. So I have two different variables and the answers to those questions are numbers. So my variables might be, the one we've done in the past has been like casino size and revenue, or number of cars you have, and rental car and income. And what are the answers to those? You know, how much income did you have last year and how many cars do you have? I'm not going to say blue. I'm going to say I have 20,000 cars or whatever, right? It's going to be a number. So when your variables, the answer to your variables are numbers, and also you're looking for a correlation between them, then this is when it's chapter 10. Those are kind of your hints at chapter 10. And you'll have two lists of data that are matched up X and Y. The next one down here, the chi-squareds, are when you have frequencies and they're in categories. So here, your data, your answers to your questions are categories. They're basically tally marks in different categories. So, like for example, what kind of dog are you? And are you male or female? What's your gender? Those would be, I'm a yellow lab and I'm a female, right? That would be, those are your answers. Your answers are categories, right? Labels. If you're only answering one question, one variable, then it's going to be 11.1. Like, what's your favorite flavor of ice cream? Or what's your favorite flavor of soda? Or what's your, what kind of puppy are you? If I just asked you just that. Then, that's where you use that observed minus expected thing. And again, these are always going to be, chi-squares are always going to be frequencies in categories or proportions. They may say any of those words in there. The chi-squared matrix is when you have two variables, right? So you've got this whole thing going on. So you have categories up top and on the side. So these little highlighted things, the things that aren't dark, those are categories. Categories on the top and the bottom. And your data is inside. It's this nice little matrix inside. So that one's a little bit easier. You put it into matrix A, stat test, chi-square test of matrix A. I think it goes A and B, and then calculate. But the B, you have to put anything in the B, because it will calculate the B for you. We talked about that last class. Remember, it calculates B for you. You just input A. And then the last one down here, we've talked about this group, is ANOVA, and that's when you have three or more lists and they're asking if the means are different. So that they're going to talk about means with this one. If they ask you about means in there, it'll say means or averages in there somewhere. Then that's the ANOVA. I also did this for my night class, which kind of made sense after I kind of thought things through. You can kind of look at here and say, well, are there two variables or are there one variable? And then are the two variables, are they categorical or are they numerical? If they're numerical, then it should be linear regression with a PPMC table, and you're finding R, and you're given pairs of data. Your data is pairs of data. If your two variables have categorical answers, then it's a chi-squared, right? Because you're talking about categories and talking about frequencies and proportions. And that'd be, there's two variables with categories, two variables that each have categories, then it's a matrix. If you're only talking about one variable, if it again, your data can either be categories or numbers. If your data is categories, then again, that's a chi-squared list. So again, same thing, frequencies and proportions come into play in categories. If it's numbers, then it's probably three different means, and you're looking at three or more means. You're looking at ANOVA. So it should have three or more lists, and so it looks like categories, but it's really three groups. right? Like high blood pressure, low blood pressure, medium blood pressure. And it's the three groups that we are finding data from. It's not asking you, are you high blood pressure? It's saying, if you're high blood pressure, what is your IQ score? If you're low blood pressure, what's your IQ score? So it's asking you a question and it's going to group you based upon what group you're in. So, oops. Let's try that again. So you guys take a look at this one and try to figure out what it is, which one it is. And I'll give you guys 30 seconds. Or I'll give you a minute.
Which one did you point to, or are we just figuring them
All